Welcome to the Crazy Hat Chemist. Here we go, the 5th video on stoichiometry. Today we're going to be talking about percent composition from the formula. So here we go, bam! Okay, determine the percent composition of calcium nitrate. So the first thing that we need to do is get the correct formula for calcium nitrate. Calcium is a group 2. It has a 2+ charge. Nitrate is a polyatomic ion, and that is NO3 minus 1. So we're going to take that 2+ charge, that 1 minus charge, absolute value of those two numbers, flip them, bring them down, and you're going to get your formula right there. Isn't that beautiful? So how many calciums do you see in this formula? 1. How many nitrogens do you see in this formula? 2. You're distributing that 2 outside the parentheses. How many oxygens do you see in this formula? 6. All right, so from those numbers and your periodic table, you're going to determine the molar mass of calcium nitrate using the correct number of what? Yeah, you're going to round it correctly so it's the fewest number of decimal places. So once you get that, pause the video, get the molar mass for calcium nitrate, and here it is. That's 164.09 grams per mole. It has 2 decimal places and a total of 5 significant figures. So now what we're going to do is we're going to get the percent of each element within this compound. So how many elements are in this compound? There's calcium, there's nitrogen, there's oxygen. So there's a total of 3 elements in this compound, so we're going to get 3 percentages. We're going to get 1% for calcium, 1% for nitrogen, and 1% for oxygen. Okay, so how many oxygens are in here? 1. We're going to take the molar mass of oxygen times 1, and that is my numerator term. My denominator term is the molar mass for the entire compound. That's the 164.09. So then I'm going to multiply by 100 because I want a percentage. So this is my setup. That is 1 calcium times its molar mass, which is 40.08, divided by the molar mass of the entire compound, 164.09, and then the whole thing multiplied by 100 because I want a percentage. Okay, now the next thing I want to do is I want to do the same thing for nitrogen. I'm going to find the molar mass for nitrogen. I'm going to multiply that by 2 because I have 2 nitrogens. That's my numerator term. My denominator term is going to be the molar mass for the compound, and that is the 164.09, and that's that setup right there. Of course, I am multiplying this by 100 because it's a percentage that I want. The next thing I want to do is get the percentage of oxygen. And how many oxygens are there? 6. I'm going to multiply the molar mass of oxygen that's on the periodic table times 6. That is my numerator term. My denominator term is the molar mass of the entire compound. That's the 164.09, and I'm going to also multiply this by 100, and so I get a percentage. So, the 1, the 2, and the 6 are just counting numbers, so those have an infinite number of significant figures. So then I just look at the molar mass for each element, and then the molar mass for the compound to get the number of significant figures in my answer here. In 40.08, there are 4 significant figures. In 164.09, there are 5 significant figures. So after I do this little division multiplication problem here, I'm going to get 4 significant figures. So that's why it's 24.43% of calcium. Number, units, formula. I'm going to do the same thing with the nitrogen, but the nitrogen has 1 more significant figure, so it has 5 significant figures in the molar mass for nitrogen and 5 significant figures in the molar mass of the compound. Therefore, I'm going to have 5 significant figures in this percentage. Okay? I'm going to do the same thing with oxygen. Oxygen has 4 significant figures in its molar mass. Remember, the 6 is a multiplying factor of an infinite number of significant figures because it's a counting number. How many oxygen? 6. And then the molar mass for the whole entire compound is 5. Okay, and by the way, the 100 that you're multiplying by, that's an infinite number of significant figures because you have the total, and the whole total is 1, like 1 pi, which is 100%. Okay, now you should see if you add up these numbers here, you're going to get 100. Now you might not get exactly 100 because you have rounded these numbers, but you're going to get something very, very close. If you didn't round these numbers, then you would get exactly 100. And all of these answers that are in the yellow have the number, units, and a formula. So hopefully that first example worked really well here for you. I'm going to move faster on this second example, not like I'm not moving fast. So here we go, second example, boom. We're going to determine the percent composition of plumbous phosphate. So again, the first thing we need to do is get the correct formula for plumbous phosphate. And plumbous is lead, and plumbous has a 2+ charge. Phosphate is a polyatomic ion. That's PO4 3 minus. I'm going to take the 2 and the 3, absolute value of those two numbers, flip them, bring them down, and I'm going to need a parentheses around the phosphate. So I have PB3, PO4 parentheses, and a 2. So the question is, how many leads do I have in this formula? I have 3 leads. How many phosphorus do I have in this formula? 2 phosphorus, because I'm distributing that 2. How many oxygens do I have in this formula? I have 8 oxygens in this formula. So now what you're going to do is you're going to pause the video really quick and get the molar mass for plumbous phosphate. You're going to round it correctly using the least number of decimal places, because your last operation in determining the molar mass is addition. So here we go. You should get the molar mass of 811.5 grams per mole. Now what you're going to do is going to get the percent of lead, percent of phosphorus, percent of oxygen. Okay, you're going to take the molar mass of lead times 3 divided by the molar mass of the compound. Then you're going to get the molar mass of phosphorus times 2 divided by the molar mass of the compound. Then you're going to take the molar mass of oxygen times 8 divided by the molar mass of the compound. Each one of these steps you're going to multiply by 100, and then that will give the percent of lead, percent of phosphorus, percent of oxygen, respectively. So here we go. This is the percent of lead in this compound, and here's the number. Then we have the percent of phosphorus in this compound, and here's the number. Then the percent of oxygen in this compound, and here's the number. You should see that I've maintained the number of significant figures correctly, and that is 4 in all these cases. You should be able to add up these numbers and get 100% or something very close to it after you've rounded them correctly. And again, number units formula for every single one of these problems. So I was at a college campus, my local college campus over here, and I saw this on a kiosk. Check this out. Do you need a roommate? I think we have the right chemistry. So you're going to call 6.022 times 10 to the 23rd. That's Avogadro's number. And you should see that Mr. Avogadro already has two numbers taken off. So I hope you really hurry, because I'm a chemist. And we are teaching chemistry right here. Bam! That was the 5th video in this series. I'm hoping you're having a great day. The next time, look forward to it. We're going to do empirical formula calculations, and we have 3 subset videos on that one. I'll see you then.